Okay, let's look a little bit about breadth first search, and here we have example graph like this one, and we have breadth first algorithm which tries to find a path from start node to goal node, and it returns a list about those nodes which we travel through on that path. And let's start. We have at first vertices, and it is array where we store our indices, vertices. So like this. And this contains those vertices, and we have also list of connections. So we have adjacency list about those connections, but let's start with vertices. So at first we have array where we have 1, 2, 3, 4, 5, 6, 7, and 8. And we have also those adjacency list, but we are not going to present it here. So there should be 1, 2, 3, 4, 5, 6, 7, 8, 9 connections between those vertices. But we don't write it up. But when we start this algorithm, we start with creating some arrays and one GUI and one list. And at first we create that parent visited list, so we haven't yet visited any of those vertices, so we set visited, and it is array with boolean variables, and we set here uh, false, false, false. All nodes or vertices has false value because we haven't visited yet for those. Then we have parent list, parent, and here we set parent value to -1, so every parent is now -1. And then we add new GUI, and it is important. And it is currently empty, so we don't have anything on that GUI. And also we create list, which is path, and I set it here down corner, and it is empty. And now we have that much data, and also about data about those connections. Now we set that where we start, we set that true. So I am going to start from number 1 here, and for number 1 it is index 0, So here I set this visited value for true, and parent value, we don't have parent yet, and we set the start node to that GUI. So here we want have 1. And if this GUI is not null, so it is not empty, we start doing that loop. And at first we set current value at first in that GUI. So now this one is current. And it also pops that value out of that GUI, but I don't do that yet. So I keep this number 1 here so that we can check other things. And we check if we have reached our call, and I can set, for example, that we want to go to number 7, and we skip this one now, and this part here is our main part of breadth first search, because if we do we can do different things with breadth first search. So this one is particularly at finding a path from start to goal. We can have different goals when we are using breadth first search, but this time we are doing that path finding. And let's see, at first we look all neighbors which are from adjacency list, this current node. So we do have 2 neighbors, and those are this connection and this connection. And we can start first from this connection. Let's think that this one is first on this adjacency list. So if this neighbor is visited, we check here from number 3. I have different index here, but I think that if we check neighbor 3, it checks from index 2. So now we have in node 3, it checks it is not visited yet, so we are going to do this loop. So what it does, it sets visited for true, it sets parent for that neighbor, that current value, so it sets here that parent for node 3 is 1, and it at last it GUIs that neighbor, so we add number 3 to that GUI. And next it is going to loop this adjacency list, so we are going to loop next this one here, and we find node 2 from that adjacency list, and number 2 is not visited, so we set true. Now we have visited on that node, and we set also that parent is number 1, and after that we set this number 2 to that GUI. So here we set number 2. Now we have done everything here, and as the beginning we deguied that number 1, but I am going to do it now. Because we need that value to show here. But we went into this while loop and we start again here. So this GUI is not empty, so we are going to set current next item on this GUI. So now this one is current. So on our graph we move from number 1 to number 3. This one is our current value. And we are going to look if we get to our goal. No, we haven't. 7 is our goal. And after that we start checking all neighbors from third adjacency list. And here we start with this connection, and it is third one which we check out, and we try to find that neighbor if it is not visited, and it is not, because number 5 is not yet visited. We set it true, and we set its parent to number 3. Then we check, we set that number node 5 to our GUI, and we have done. Next we check other connection from number 3, this one, and we are going to find node 4. We set on number 4, we set that we have visited that one, and we said that we said that the parent is 3, and then we set that number 4 to our GUI, and we have done everything because we have checked for each loop we have checked all neighbors. So we have done this one, and we can go to next one. So number 3 is done, and as we removed it from that GUI here, we don't know anymore have that number 3. Next we are going to look things from node 2. This is now our current node. It is not our goal node, so we don't do anything here. Next we are looking all neighbors from number 2, but we don't have any edges from number 2, so it does nothing, and we have done this while loop, and we can remove that 2 from that GUI. So we were here, and now our next node to check out is 5, so current is no now. And next item on GUI, this is current. And here 5 is not our call, so we said that we skip this one and we start looking neighbors from 5's adjacency list. And first one, we are going to look this connection, and number 8 is not yet visited. So we set here that we have visited true, and parent is node 5. And like this and this, and now we add that neighbor, so node 8 to that GUI, and we move to next neighbor, and here we have next connection, this one, sixth connection, and we haven't visited on number 7. We set this one to true and this one to 5, and we set this one to GUI, so 7 here. Now we have done everything from number 5, and we can close this while loop for number 5. Next one is node 4, and we are going to take it from GUI, and we are going to look all neighbors. And at first we look here and we find node 6. Node 6, is it visited? Not. We check that. Next one, next, and we set true, and parent is number 4. And we set his number 6 to GUI, and we have done this one. We have other neighbor from node 4. This is 8 connection that we check out, and that neighbor is node 2, but node 2 is already visited, so we don't do anything here. So let's move a little bit this GUI. So now we have been in this current, and we have checked all its neighbors 6 and 2, and everything here is done. Next, we are going to look here, node number 8. It is not our call node, but we are going to check all neighbors from that node 8, and it has no any neighbors, so we skip all this. We do not set any new nodes to this GUI, and we have done. And GUI is not empty yet. and we start doing this one. So we set that 7 is our current node. And now we find that our current node is goal node because this is our goal. And what that means, we said that our temp is goal. So temp is going to be 7 at first, and while that temp value is not -1, we add this one to path. So we add 7 to our path. Then new temp value is parent for that temp value. So 7th parent is 5. We set 5 here. We remove this one and set new value for that temp. And after that, we make this while loop again, and we add this temp to that path, and we set new temp value, and number 5's parent is number 3. And we do again this while loop. We add that value 3 to our path list, and we change that third parent is number 1, and we set it here, and we set new parent, new temp value, and number 1's parent is -1, and because it is same as -1, we don't anymore do this one, so we don't add that anymore to that list. And at last we do reverse here, so it reverses this list. So we have new reversed list 1, 3, 5, 7. And now it returns that path. So this is result of our work. But we have uh, very many similar algorithms what we can do with a breadth first search. This is just one example that we find path from one node to other